pressing the button. Okay. Good. We are live. Hello, everyone.
Hi, everyone.
Yes, my name is Nick, and my co-host is Ilya. Hello, Ilya.
As usually. Hi, Nick.
Yeah, and we have very interesting guest today, Tomáš Vondra. Hello, Tomáš.
Hello.
Yeah, I read a lot of your blog posts, articles, slide decks, like benchmarks, and benchmarks is like always very interesting pictures and very good food for mind. So thank you for all this work. Especially, I remember like jumping from
So basically a food blogger.
Yeah,
Mindful blogger.
Mindful blogger. So, but especially, I remember, like I returned to it many times. I remember your material about different file systems and how Postgres behaves on ZFS, Ext4, and so on. It was very interesting and useful for me, particularly because we use ZFS for our tool extensively. We have like special tool for Postgres on ZFS. So I returned to those benchmarks to get insights from them. But unfortunately, it was long ago. So I will start from very like specific question. Do you have some plans to return to this topic, file systems and Postgres, and refresh it? Maybe.
Yeah. So first of all, happy to be here. I've seen some of the past episodes of Postgres TV, so I'm very pleased to be here,
Cool.
especially given the circumstances and no opportunity to meet in person because of the pandemic, right? So it's very nice to have a chat about Postgres and maybe a bit of rant about users. About the topic, yeah, I do a lot of stuff about performance because that's kind of what actually got me to Postgres, that I started to working with like web applications and so on, and we've been using databases, and there was no one actually to look into the performance issues, right? So that's how I got into Postgres, because I became the developer who had to investigate that, and I find it interesting. So yeah, the file systems benchmarks, I definitely do plan to run something, run some of those benchmarks again, because as you mentioned, the benchmarks I did were very old, both in terms of like the operating system years and both in terms of like what Postgres implemented since then, right? So I think it was before 9.4 or something like that.
It was long before I've seen Gate and things like this. So
yeah, definitely before that. It probably was like before the kernel 5.0 was released, right? So there has been a lot of new stuff in the operating system, and also there's a lot of new hardware, right? So the storage engines, the storage systems that we use now are quite different from what it used to be maybe 10 years ago, right? So I mean, like, we have much more flash and network attached storage. That's probably the default nowadays. It used to be very different.
Yeah, it's quite interesting, because then we all started, it was most likely 100% of SCSI, rotating disk and things like this, but now new stuff is quite different. When actually did you start with Postgres? Was it version 7 or something?
Sorry, was it?
Was it version 7 of Postgres, or which one?
Yeah, so I my memory is not that great, but I think it was like 2003, 2004.
It's most likely a 7, 8-ish something. Yeah.
I think it was right before 7.4 and 8, I think. I know that it was before auto vacuum was implemented and enabled by default, right? So
it was
that was quite
maybe
old.
8.1 or something like this.
Which happened in 8.1, I think. I think in 8.2 it was enabled by default or something.
And if you then was the person who was actually troubleshooting Postgres for employee that time, what was the most challenging Postgres that time for you? Like, what was the common task to troubleshoot Postgres? Do you remember?
So I do think, honestly, most of the performance issues we had back then were because of developer stupidity on our side, right?
So something did not change.
Yes. I mean, I've probably described or told the story multiple times to people at conferences, but how we actually got to Postgres was quite funny because the company I worked for was actually using MySQL back then, and it worked fine. I mean, like it was OLTP web application, probably a good match for like even MySQL, and there was like occasional case of data corruption, but that might have been for many reasons. And suddenly the company which was operating like online pharmacies or online shops was having performance issues, right? The database couldn't keep up. And so they started looking at like different databases, obviously. And
yeah, of course, then database doesn't keep up, you change the database.
yes, so they started looking at like Oracle and buying Oracle licenses and stuff like that. And we've been young engineers, fresh out of school or something like that. I've been actually still at the university back then, and we started looking at like different open source databases, and we switched to Postgres, and that seemed to work quite fine. But we ultimately found that actually the the performance issue was entirely the fault of the application, because the application, instead of fetching all the results at once, it kind of fetched only the IDs of the products, for example. And then for each field, it needed to print like a title and price and manufacturer. It did another query, right? So if you needed
sounds
to
like
print
a
like
Hibernate that time.
yeah. So we fixed that in the application, but we kind of stuck with Postgres because we needed or we liked the features it actually had. It seemed more feature rich and reliable and so on.
No, it's even version 8 was like quite rich about features that time as well.
Yes.
Yeah, it's extensibility also like I remember like I liked extensibility especially because you can write your functions, procedures, and even language, add your own language and so on. So a question, but what did bring you to deeper working with Postgres, like to work with Postgres deeper, like to start like I don't know, like to hacking and benchmarking and so on.
Basically, you started as user and then you switched to improving things.
I started as a user, but I started to dig into the internals. And I think what actually got me to actually work on the Postgres itself, I think large part of that was the community, right? I started looking into issues in our application, and I found that the community around Postgres is actually quite open, right? And if I wanted to develop some small features, the people on the mailing list were very helpful, or it seemed to me like that, right? I haven't tried that in the MySQL world, so I can't really compare. Maybe the MySQL community would be just as nice, but I think the community of Postgres was one of the reasons what actually got me into working on Postgres more, because it's not like a product developed by a single company who's like pushing to sell more licenses. But if you go to conference, you will meet engineers from different companies that have exactly the same access to all the code and can do whatever you want, right? So, and we are kind of colleagues. We are not competing with the engineers directly. So,
do you remember actually what was the first idea, what you needed to improve in Postgres? What was not from the box, which you tried to implement yourself?
so I think the first thing I implemented was something in the statistics collector. I think I have provided some feature for like monitoring temporary files or something like that. And I know that I think Magnus actually committed that. And I'm pretty sure that was in Stuttgart in 2010, I think, probably.
So
And
for your input, we need to blame Magnus as well.
Yes. So I think that was, if I remember correctly, that was on one of the conferences. I have developed a small patch. Magnus committed that, and that was it. But until then, I've been like developing like things around Postgres, not the code itself. I've been mostly like developing stuff using Postgres. Yeah.
Nico, do you have a question?
So yeah, you're right. Yeah, so I have a question in our chat. Why are you doing development related to statistics in Postgres, which is an unusual but very important area and quite often neglected by many others? So it's already like you almost answered it. So you started with statistics collector and temporary files, and like, but I suppose you had some problem in real life, right? Because of like,
yeah, I have many problems in real life, right? But I'm not developing code for that.
Right.
Well, I would say one of the reasons why I started working on statistics on the optimizer, because the first patch was about statistics, about monitoring, right? So we needed to monitor something. We had problems with like queries creating a lot of temporary files.
Right. So I confused, as usual, I confused two different statistics. One is for observability, another is for optimizer, right? So I confused it.
Right. So the first patch was about observability, but what I focus on, or one of the things I do in Postgres are statistics for planner, for optimizer. And there are multiple reasons why I do that. First, I have studied statistics, right? So I have a degree in mathematics, and statistics was fun. So I think that's interesting. The other reason is that I think it's incredibly important part of the database engine, right? If you want good query planning, you need good input for the planner, and you need to be able to make reasonable decisions, properly costing the queries and so on, because only then you can actually make the correct planning decision. I mean, it's kind of useless if you have very good execution engine, but you are choosing the wrong query plan, right? That's kind of wasted effort. So that's why I'm looking into and I'm trying to improve the optimizer. I don't think it's like a silver bullet, because there will always be cases when the statistics are kind of wrong or are not actually sufficiently representative for whatever reason. But and in that case, we need like some smartness in the execution engine. But I think improving both parts is important.
Actually, one of our topic for today was planned as speaking about the ideal database, and you are busy with optimizer statistics and optimizer for like a long time. So, what do you think? How ideal is optimization of queries in Postgres right now, or it's totally wrong, outdated, old? Nobody does it like this today. So, what is state of the art of optimizing queries in Postgres?
Well, I think it's pretty good. I think there is always kind of like a feedback loop, right? It makes no sense to create a perfect database, which is so complex no one is going to use that, or there is so much overhead for uh, the regular use cases that it doesn't actually give any benefit. I mean, I'm sure there are workloads and data sets where we will do the wrong query planning decision, or I'm sure there are query plans that we actually can't generate at the moment, right? Because we just haven't anticipated that. But I think it's pretty good. I think we are constantly improving that, which is kind of double-edged sword, because every time you improve the optimizer to make it smarter and to give it more options, you kind of give it more chances to get it wrong, right? So it's kind of, you need to make trade-offs. You need to consider some safe decisions and choose those. What I meant by the ideal database is something very, very different, though. I wanted to invent like a topic for this to that would allow a bit of ranting about stuff we find frustrating. And one of the things is that the engineers that are working with databases kind of ignore all the complexity that is in the database, and they
So
have
that's
in
why
their
you
mind,
prefer the online format to that, because otherwise they could
have
punch you.
they imagine how an ideal database would work, and then develop against this ideal database. And then when something goes inevitably wrong because there are limits and requirements that they haven't considered, suddenly it's the database's fault, right? And it's kind of frustrating for us, because we know what the complexity in the engine actually are, and we understand that we can't do something because it's not possible because of limitations, for example, in the operating system or in hardware or something, or because we need to provide features like isolation or transactions or something like that. So we need to have
why, for God's sake, we can basically be schemaless, and that would be enough. It would be simple and good.
Yeah,
why not?
In that case, probably you shouldn't use Postgres, right? I mean, like if you don't need this overhead, which is perfectly valid engineering decision, it's kind of strange to blame the database for actually doing that. But I don't really want to sound like I hate users. The fact is that we do exactly the same thing with respect to the other layers in the system, right? So, for example, we are developing against operating system, and sometimes we are kind of frustrated that we don't understand why the operating system is doing something the way it's implemented, right?
So you're speaking about fsync things.
Yeah, so for example, the
example.
fsync is a perfect example, right? So we've been developing, and it worked for like 20 years. We've been developing against ideal implementation of fsync, right? Because
and nobody cared.
it made perfect sense that it should be implemented like that, except it wasn't, right? And we could probably talk about like if it actually made sense, or but that doesn't matter, right? I mean, like there was a decision at the operating system engineering why it's implemented like that, and we haven't actually realized that.
What can be actually improved in this area? Because we always tell to developers, like, guys, learn SQL, try to use explain, try to figure out at least a bit what is going on under the hood. What we can do to improve our understanding of operating systems for Postgres needs?
Yeah, I don't know. I think we need to be careful to explain to the people that simply we are providing a nice API, essentially, like we are providing a nice interface in SQL, but there is a lot of complexity behind that, and they need to be at least open to the idea that it's more complex than they think. I don't have a better idea how to improve that, because I don't think a single user can actually understand all the details of all the layers, right? They essentially are using the database to get rid of all those details to some extent, right? And even if they understand, for example, Linux, maybe it doesn't work for some of the BSD versions, or maybe it doesn't work for Windows. I don't know, right? So I don't think it's possible to understand all the details.
Returning to statistics and optimizer, what do you think about genetic query optimizer in its current state? It's kind of a very old code, right? So, and do you think it's still relevant for Postgres, and should it be improved or changed somehow for future versions? What are your thoughts?
Yeah, unfortunately, I don't know anything
Nobody
about
knows.
the query optimizer.
Oh, okay.
My impression from like what other developers said is that it was a nice experiment, but it's not perfectly
okay. Right. This is what I expected, actually. Okay, and in this case, next question. You created you're the main author of extended statistics, create statistics, and so this is nice feature. Did you consider to implement it in more automated fashion? Like, for example, somehow Postgres creates it automatically, or suggests you to create it, proposes. Did you have such thoughts? Because what I see in the real world, very like only good experts use it. Many people just avoid using it because they don't understand it fully. They didn't have
or just they don't know about existence of the thing.
Existence, or they don't understand statistics very well, and they don't have very good education in statistics, for example. So it's quite difficult for them to start using it. But it's a very good feature and very helpful in many cases. I saw cases when performance improved drastically because of when we start using it. So what do you think about like?
Yeah, extended statistics are like a way to provide the optimizer with additional information to make the correct decision for execution, right? So if the optimizer was doing the wrong decision before, and we correct that, it's going to be faster. And it could be, we can probably construct examples where it's like arbitrary speed up, like 1,000,000% or something like that. But I do agree that it would be nice to have like statistics advisor that would, for example, look at all the conditions in all the clauses in queries, and would say like, well, this was misestimated very often, and the resulting query was taking very long to actually execute. So maybe if you improve that, if you improve the estimate, you would get a faster execution. So I think that's definitely something I would like to work on. But at this point, I've been mostly working on on the infrastructure for like the basic statistics.
Yeah, when you put this when you put this topic in this way, it immediately makes me think that it also like it's similar to indexes. It would be also good to have index advisor, but we don't have it in Postgres. We have some projects outside of it, but not internally.
So
right, very similar, I think.
Right, and I don't think the fact that those projects are external, I don't think that's an issue, right?
Okay.
Because once you actually put something into the Postgres core, that means that you are automatically tied to the release cycle of Postgres. So you have like one major release per year, and that's it, right? And you can't actually provide new features in minor versions.
Yeah.
So you are only going to have like you will only get like bug fixes and so on. So I would actually say that having those projects as external would be preferable in my view. It's a bit of like a chicken egg problem, because if you don't have the project, if you don't have the at least like a prototype, it's very difficult to say what needs to be changed in the core, right? Because you will probably need some callbacks, some
and this interaction would be probably less efficient.
Yeah,
as we all see on pitch-start statements, for example.
Yeah,
it's like very external.
I cannot avoid asking question. What do you think about hints for optimizer?
I mean, I'm a bit torn. I'm always advocating for actually fixing the issue and improving the optimizer, but on the other hand, I don't think it can ever be perfect. So I think when used reasonably, just to fix a couple issues, it can actually be useful. The problem is that you then need to maintain a complete, like, I think it complicates the query optimizer quite a bit. But I haven't really thought about the implementation at all.
An interesting thing that many people who experience it in writing something for Postgres, I mean internally, they always try to implement something which improves optimizer using hooks and things like this. So substitute parts of the optimizer for some reason and so on. Does this approach have any positive things?
Well, I think it essentially what you can do now is you can completely replace the query planner and use whatever you want that is in your extension, right? So that actually works. I know that some products are actually using that. If I'm not mistaken, I know that Timescale and Citus were actually doing some smartness with rewriting queries and so on, which I think is perfectly valid, and it shows that it's great, right? It works the way it should be working. I don't know how else actually could we provide such functionality without having a lot of more complexity in the Postgres code, right? Which would then be kind of difficult to test, maintain, and so on. So I think this is kind of like ideal solution in a way.
Mm-hmm. Interesting. If we should provide actually some sort of like integrated optimizer for most of the ORMs, like to just switch it off and connect directly to the programmer's brain instead of ORM.
I think it's kind of maybe, but if you allow, for example, optimizing some of the code, some of the queries differently, having like a modules that are used to build the optimizer, I think that kind of could break a lot of stuff in the code, because there are dependencies between like optimizations in different levels, right? So optimization, for example, at the upper parts of the plan will probably depend on
how many rows
the
returned.
the input parts to be generated correctly. So I haven't really thought about that very much, but I think there's a lot of like assumptions about what the other parts of the optimizer are doing. So I think we need to be careful, and that's exactly why just providing either the hooks in certain parts of the query planner or allowing to replace the whole optimizer essentially are kind of sensible options. I don't have a better idea how to do that.
There is a question in the chat very close to this topic. A question
Actually,
about
two of them, yeah.
Right. A question about improving the Postgres planner in the direction of data warehouse OLAP planning. There are hackers thinking it should be like optimization straight GUC, while others think it should be feature by feature GUC, like variables, right? So optimization parameters. What do you think about which way is better? The way which is the way forward?
So I'm not sure I understand the question exactly. What we do have now is essentially the feature by feature switches, right? So you can enable, disable feature,
sequential scan or index
sequential
scan,
so on. I know that what was proposed before was like a single GUC, which would say how much effort do you actually want to put into the query planning, right?
Mm-hmm.
And the warehouse environments would probably say, okay, so I want to spend a lot of effort, because even if we speed up the query twice,
it would be
it's still saving much more time than.
And we probably can spend more time in planning.
Yes. And in OLTP environments, it would be like a different, the budget would be much lower. But I don't think we actually implemented any of that, right? Because it's exactly one of the global features in the query planner that affects everything. And I don't know exactly how would that be implemented. I know that there were questions or proposals to have to essentially this one option enable and disable certain other options. So for example, we would enable some additional experimental or more expensive optimizations or something. But
used to be this joint collapse limit and things like this for complex OLAP queries. It could be probably some sort of a magic switch.
Something like that. I mean, I think the idea with a single GUC would be that you would say, okay, so the optimizations for data warehouse, and it would increase these limits, for example, to double of the default. It would probably enable just-in-time compilation and stuff like that. I don't know.
Maybe extend the number of buckets in statistics, like a default statistics target, or like per table or per something like. But it's like also interesting topic that some people like by default it's 100, right? But some people increase it, and even in OLTP they need to increase it to have more precise decisions made by planner to 1,000, for example. 1,000 it's quite common. I saw it many times. But it's also like a question how it affects the planning time, right? So we will see only when everyone switched to, in Postgres 13 we have it, right? So we have it in PGSA statements, and in explain we have more metrics, and planning time is there already. So we will see only soon, like in 1 or 2 years, when people migrate to Postgres 13 or later. So
yeah, I
kind of.
I definitely do discuss the statistics target with customers once in a while. I don't think there's a lot of reasons to. I've seen cases where people lowered that, so instead of 100 they use 50, but that doesn't really save anything, right? I mean, like the difference in performance is negligible. You will get slightly less accurate statistics. It's not going to be terrible, but it's not going to help very much. I mean, it might be 5% difference or something like that at most. Just to explain a bit, I mean, like 100 buckets means that you have accuracy of 1% essentially, right? For range queries and so on, or something in this ballpark. If you have 50 buckets, you will have smaller sample size used to build the statistics, and you will have like 2% accuracy roughly. I think increasing the statistics is like a difficult question because if you increase that to 1,000, you will get like 10 times more accurate estimates for certain types of queries. So, for example, range queries,
certain
right,
types of data in your tables, actually, not for one and each.
But I don't think this actually makes a huge difference for most query planning issues that we have, or estimation issues. I think in many cases it's more like because of some implementation detail, it has a side effect that it actually improves the query planning for some reason. But it's not like that the statistics or the estimates would be 10 times better, right? It definitely does not. So I would be careful about that. I think the 100 is probably okay for most cases. If you need to increase statistics, maybe try that, and maybe increase that just for a single column or something that actually where it makes difference. But increasing that globally in the whole cluster is probably not a good trade-off, because it also means that you need to sample 10 times the amount of data, right? So for
analyze takes longer. Like
yes. And it uses more I/O, it uses more CPU. And if you have tables that are large or updated frequently and needs auto-analyze frequently, you may actually lose performance because of that, right?
Much overhead. Okay. So you don't recommend setting 1,000 without proper analysis, and
I definitely don't recommend just doing that as part of the initial tuning without actually looking into slow queries and investigating if it helps, right, at all. Because you are just kind of throwing out money out of the window and hoping that it will help something.
By the way, how would you recommend like to investigate it? Because, for example, if we have this idea, somebody told us that it's a good idea. How can we check it? Like we have production cluster.
I could ask the same thing, right? So how does the person know that it's a good idea?
Okay.
I mean,
method.
I mean,
you used to work a consultant.
Engineers tells you something without actually giving you any evidence. I mean, he's
well, okay.
Right?
Next level. This guy brings, or like, like this guy brings you some evidence that some query improves.
Like, and that may actually be the best idea, right? I mean, like, collect some slow queries. Maybe use PG test statements or something. Maybe then try to change that in production. Maybe double the value, or you might even use the 1,000 or something.
It's most likely relatively safe.
Compare the results to what you had with the old value, and if it helps,
here we touch He would touch my favorite topic, experimenting right on production. I'm strongly against this topic, and like I mean this approach. I'm advocating to avoid it, and so okay. But we will not go in this direction deeply. But I think experimenting on a clone would be better, right? So you can run explain on a clone. You don't need to reproduce the whole workload.
Yeah,
you just need the same statistics, maybe same data. By the way, there is an interesting extension that allows you to export and import statistics, and you can export statistics and import it to basically empty database and like fool the planner. Did you hear about this, or maybe you
No,
know
I
something?
didn't hear about that, but I don't think it's actually useful in this case. You should always do you can of course do the tests on like a clone of the database, right? You should use the same amount of data with the same data distributions and so on, because otherwise you are testing something which is irrelevant.
You will not see real execution plan, right?
And then you need the queries that are executed on production, which might be generated by like your scripts, or it might be actual user workload or something. I know that there are companies that are essentially creating a clone and then redirecting or creating a copy of all queries.
Mirroring, right? Mirroring.
Right? And they are kind of testing it this way. So that's also possible. I understand the concerns about doing tests on production. Yeah, I understand that. I have seen cases where it backfired quite badly. I think in this case, in increasing the statistics target, the risk is fairly low, right? And if something goes wrong,
yeah, right,
you know how to actually fix it, because you can decrease the value, run analyze again, and you are kind of okay, right?
Right, but I agree. But I would like to connect dots here, because this is what I'm working on for like a couple of years already. If we return back to the ZFS topic I started with, we use ZFS to create thin clones of production, and we have like a follower, like a standby, so we have constantly updated database. But with ZFS we can provide thin clones, and you can run explain right there. You have the same data, the same statistics, and you see production like plan, but with different state of caches, of course. So like,
and we're constantly fighting with Nikolai about the idea that it's not the proper workload. It's
not a proper
without concurrency and so on.
Right, but there are many types of analysis you can want to take. If you want like load testing, of course this is not a viable idea, because you will different file system, different behavior. But if you want just to explore how the optimizer behaves, to see explain plan, this is a good idea, and ZFS can provide clones in a few seconds. So it's very.
But by the way, I have a question, related question to Tomáš about this. Then you're hacking on optimizer. How do you, as a developer, as Postgres hacker, test yourself that your feature is useful? What you're starting with? You run it on your laptop or what? How do you figure out that what you just done is good for optimizer or not?
So first of all, I'm not usually starting with like I don't wake up in the morning and say like I will do something for optimizer, right? It usually the thing that forces me to do that is like a problem at the customer, right? So they are struggling with a slow query or something. We are investigating like why doesn't it work better. We are discussing that with other engineers, like how else could we actually execute a similar query, or what other databases are doing, and so on. And then we are kind of experimenting with how to convince the optimizer to do that, give the optimizer more information, change the costing, and so on. And ultimately, you need to do some benchmark comparing the original plan with the new plan, right? So you do kind of expensive or extensive testing first, it might be on small data sets on your laptop. You need to be careful about like the hardware limitations of laptops, of course. But then we do testing on like beefier hardware. So for example, I have my personal machines in the office with like gigabytes of RAM, different NVMe storage, and so on. So at that point, I can kind of say that the improvement actually is real. But then it of course goes through the mailing list where other engineers can point out like that you've made some mistake, you are assuming something that is not true, and so on. So I think that's a pretty normal approach to testing any improvement in general.
How I believe Andres Freund at some point used to say, I improved this and that, and then I broke my SSD because of too extensive testing, and I need to replace it.
Yeah, I definitely do that too, right? So I think the file system benchmarks that we mentioned at the beginning actually burned through my Intel SSD in one of the machines because it was simply so much writes and random IO and so on that it kind of killed the SSD. But I think that's something you need to be. It's an investment, right? I mean, like the hardware has a limited lifetime. It's okay.
Yeah, we had actually another question in chat, and probably it's like very typical question people ask to Postgres developers. What do you think about current implementation of MVCC? Was it good decision, bad decision? How it goes now? What do you think about that heap and other ideas of going away from current MVCC model?
So I personally think the Mvcc model we have is kind of interesting. I'm not sure I'm the right person to say whether it's the right design or not, or whether the undo based implementation which is used, for example, by Oracle is like the right thing, or I think each of those approaches has like different trade-offs. I think it served us quite well, right? And we are still improving the current implementation. We are finding optimizations in that, and I'm pretty sure that if we used, for example, the undo, it would solve some issues, but it also brings some other issues, right? So I don't think we are likely to kind of ditch the current MVCC and replace that with something else. I do hope that we end up with the Z heap or something eventually being useful for production workloads, and you will be able to kind of choose different MVCC implementations for different workloads, right?
So we will end up in something what we for years were blaming MySQL as inefficient, like pluggable engines.
So I don't think the problem with the MySQL pluggable engines is inherently inefficient, or I'm sure it can be done in efficient way. What I personally always disliked on MySQL approach was that the engines are kind of integrated in a kind of poor manner, so that there are like things that only work with certain
like
storage engine,
transactions,
and then when you use a transaction which uses like multiple storage engines, suddenly there are like silent misbehaviors, or it doesn't work the way you would expect, or stuff like that. I think that's one of the main things we have learned from MySQL, not to allow these incompatibilities, right? So I do think that if we ever end up with zheap in the core or any other storage engine, like for example the zstore or compressed column store or whatever, I think we will require much higher compatibility with all the other features in Postgres, right? Because that's kind of frustrating, and it's also like a food gun for the users. If suddenly you switch to a different storage engine and like half of the things doesn't work.
And people already hit that using foreign data wrappers.
Yes, but foreign data wrappers are kind of like kind of obvious, right? They are not exactly a first-class citizen in our environment, right? So I know that foreign data wrappers were used as storage engines, kind of, but it's not like a fully integrated into our transactional and visibility system.
No. Okay, so there was another interesting topic, because we are already like in the second half of our talk, definitely, which we're discussing before this episode, was about scaling, like designing the layout of databases and things like this. So you mentioned that people sometimes do it wrongly and trying to scale out too early, design scaling approaches not based on the data or something like this. So what do you think about this? Is it really a common problem or not?
So I'm not sure if it's like a common problem, because my view is definitely skewed, right? I only see the problematic issues or problematic cases. There might be 99% of databases where it's implemented perfectly and I don't hear about them. But what I deal with is like customer having issues, filing a ticket in support, and those are like that's the 1% of issues, right? But I do see this when, for example, talking to people at a conference, like they are just about to start a new product or something. They don't even have a single line of code written, but they are already talking and discussing how to actually design that for like billions of users, right? And I don't think that's really, as an engineering approach, that's really sensible, because you are wasting a lot of resources on something, and you don't actually know if you don't have any validation for the design, right? You don't know how to actually do that properly. You don't know what will be the requirements after like 3-4 pivots of the product. You don't know which parts of the database will need to scale properly and which is completely irrelevant. And you are kind of wasting the resources that you could spend on actually implementing the product, right? And actually making it work for users. So I think that's a generic problem. And I kind of see that on my patches as well, right? Because you start with like a great idea, and then to actually make it reasonable and reasonably simple and committable, you need to kind of remove 90% of like nonsense code, which is not needed actually in the first version, right? And then based on people using the feature, you can actually start improving some of that based on the feedback. So I think that's like a generic, obviously, for me, this part is natural, right? Because I do develop the code, I understand that. But it's frustrating when other people are actually doing the same over engineering stuff, over engineering issue, with the database, right? And sometimes they invent kind of neat solutions, and sometimes it's kind of more on the crazy side.
Yeah, I would say there are probably several different issues about those things.
Yeah.
Because what I commonly see, it's like people from Oracle world, they tend to use one big machine, and then they realize that there is no license cost. They try and to scale, to do microservices, to use thousands of databases for something. That's very common thing. Or people from MySQL world, they got used to everything should be scaled out to cope with the workload, and they tend to use lots of machines.
So I do think that if you really expect the product to hit the vertical scalability issue, and you can't actually do something simple like offloading to read-only replicas and stuff like that, then you are probably at the place where you actually need to think about scaling to like a sharded database and do something like that. And there are definitely things, definitely situations where you need to do that, right? I think we have customers who have to do that. My point was that when you are starting to write or develop a product and you don't have actually many users yet, the best thing I can say is that imagine you have like a limited amount of tokens, and you can spend them either on improving your product and give users some value, or you can start inventing new stuff which you actually don't need yet, right? And chances are, because you are spending so much effort on something you don't need, you will actually not succeed with the product, right? Because other people will do things better. But that was kind of my idea here. I don't have any like clear recommendation
Where to start?
where exactly is the threshold. I don't know.
And actually, it's an interesting question where exactly it is. What do you think actually? When you can start thinking that okay, this database is its limits of vertical scale. So now we have like very, very powerful servers.
Yeah, and I need to mention a very good series of articles, XXX performance since Postgres 8.3. You did very recently. It's very good. Like 3 articles already: OLTP performance, HTPCH performance, and full text search performance. So it's very good, and it was very like full of interesting benchmark pictures. So everyone, I encourage you, like go and read in Tomáš's blog posts, very interesting articles. So in particularly in these articles, you very well highlight how Postgres performance improved because of improvements in related to multi-core usage, right? So, but it was interesting to see that full text search, particularly gist indexes, degraded at some point, right? Gin improved, gist degraded. It was interesting. Fine.
So, yeah. So I'm not sure about the gist. I mean, it might be specific to this particular workload.
Yeah, as usual, benchmarks
are. Maybe it actually is something that, for example, PostGIS doesn't have an issue with because they are using the indexes differently for geometries and so on. And frankly, if you care about full text search performance in Postgres, you are probably using the GIN indexes anyway, right? So
yeah, most likely on large data sets, definitely,
right.
yes.
So I think it's something that we should eventually investigate. But on the other hand, I'm not like a just index developer. I don't know very much about that, so I haven't really looked into that.
Right. So it's like a point to explore
Yes.
in future, right? Do you have any ideas for like to continue this series of articles, because it was like good format as well?
So at this point, I don't have any like plans to repeat this, because I think I originally did this comparison like 5-6 years ago, comparing like different versions of Postgres, again like 10 years back.
And just updated, right? So new
So this
added
was
new
like
version.
redone because I learned a lot of stuff since then. I do have a different hardware now, and so on. So I have repeated that, but I don't think I need to redo that anytime soon, right? I mean, if there is an interesting benchmark, like a workload type, we may look at it. I wouldn't mind that. But I think those three basic benchmark types, like workload types, so OLTP, TPCH, and full text, are kind of sufficiently representative of.
Yeah, and covering like basic areas. I honestly, my personal opinion is that like these pictures should be on PostgreSQL website, the main website, like, and constantly updated with each new major version, or maybe even minor version as well. Sometimes, like I mean, automatically gathered all results and published somewhere.
Yeah, the problem is that these benchmarks take like a lot of time, right? I mean, like
Yes.
writing the articles is one thing that may take like a week or something to actually think about it and so on. But actually running the benchmarks, that's months.
Right. Yes. But if you automate, them, maybe like in performance load testing farms, it can be maybe somehow. Maybe there is a way to automate it fully, right? So.
Well, I mean, it's kind of automated in the way that it's like a script that I can run on each version of Postgres, and it generates some numbers and collects statistics and so on. I would love to have something like that automated. There was actually in the past a discussion about like a performance farm, something like a build farm, but with testing performance on different workloads. But that never really happened.
Yeah, I remember such discussions, and also Google Summer Code project. I suppose it was so, but you're right. It was not finished, I suppose. So.
Yeah, I think there have been like discussions how exactly to do that, how, and we kind of over-engineered that probably.
Of course.
And instead of going for like something simple, we kind of planned for a lot of different stuff and never completed that. Which
I mean, I know this place.
You could take that as an example of the scalability discussion, right? I mean, like you overdo things and you never get any benefit from that. So, yeah.
Right. Yeah, interesting comment here that you mentioned that writing article takes a week, right? Our previous guest, Hans-Jürgen Schörnig, he mentioned like 30 minutes. But your articles are very different. Like he writes very useful but very short articles. Your articles are very deep and like long, and it's like almost like a paper already, right?
And I definitely didn't mean like that I sit on that for 7 days, 24 hours, right?
Of course.
I usually have like the first draft of like what I want to say in maybe 1 hour, 2 hours or something like that. But then you go
but I'm sure you like think in background about like new ideas. This is what I usually do as well. But it's like interesting how people produce good materials, also very useful, but very different kinds. So like, okay, interesting.
Yeah, so we see Hans-Jürgen never thinks, he just writes.
Well, yeah, I think he's just dealing with some problem, write something very useful, like short, and switch to a different topic.
Yes, so sometimes then you read his posts, it's like very obvious that he just returned from a customer and was quite
right.
Another stupidity.
Fresh impression. But if you need like benchmark and like think about very various angles of view on it. So of course you need to have a bigger material. So it's interesting, and both approaches are completely valid, and both materials are very interesting to read. So
yeah, I think everyone has a different approach to writing, right? I mean, like I usually, there have been times when I thought, okay, I'm just going to write a short blog post about something, and it ended with like pages of text, right? So I kind of stopped doing that, and I write the long text anyway. So, but I think the short blog posts are very useful, because then you can actually get some information in a very short amount of time, right? It depends on what the topic is.
It's similar to what you just discussed about not accomplishing some big projects, so it's very similar as well. Okay, we had more questions, right? So like we already spent 1 hour plus, so let's discuss what we had in the plan.
Yeah, we take a look what we didn't discuss yet. We discussed scalability. We didn't discuss DB portability, actually, what we planned. So why it is actually a problem? So I agree, many people actually say we need to be database independent, I mean software developers. Is it true? Do they actually migrate from database to database twice a day, or what?
So for me, this is like one of the most frustrating topics when talking to like developers, is that they think that they can migrate their product from one database to the other. That is actually something they should spend time on, right? While developing the product. I'm talking about regular applications that you are developing in-house or something. There are definitely products that actually need to support multiple databases out of the box, because they are sold as a box essentially, and the customer needs to be able to run that with whatever database they run, right? So those are applications that support like Postgres, MySQL, Oracle, and so on at the same time. That's perfectly fine.
But they usually like cover it with multiple layers of abstractions.
I don't think it's actually that difficult. I think you need to have some layer for portability that actually abstracts the code that is specific to the database, right? But what I usually see in some database systems is, or the applications, is that they, instead of wrapping the specific code, they kind of decide that they are not going to use the specific features, right? So they kind of, the problem why it's so annoying is that they usually ignore the most interesting bits of the database, right? And so imagine running on Postgres, doing text search, but ignoring all the full text search capabilities that we have, and instead of that, just using regular like queries, right?
I have another.
That's something that works on all databases, probably.
Right. Sorry, I have very perfect example here. There's a library in Ruby called delayed jobs. And it's like implementation of our favorite topic with queue in database, queue mechanism in database. So I proposed obvious optimization, like let's create one index and let's add a couple of magic words, skip locked, to your select for update. Of course, it will speed up drastically everything for Postgres. And they still spent already 2 or 3 years past, they didn't accept the patch because they say it will not work with MySQL. So we should be database agnostic as well.
Yeah.
It's not a good approach. I think we should use all features, and skip locked is, I think MySQL already has it, by the way. So I need to remind them to reconsider it. So right.
Yeah, but that's exactly, I mean, like by using this approach to database portability, that you ignore the interesting bits, you kind of restrict yourself to the smallest common denominator of all the databases, which is like the worst part of the database, right? It's something that all databases support, and it's ignoring the interesting bits that we are proud of, right? So you probably could ignore some indexing strategies in Postgres. You couldn't use them because other databases don't allow that. You can't do like special indexing in Postgres. You shouldn't be able to use stored procedures because those are different in different databases and so on, right? So those are things that I kind of dislike about this approach. What I have like migrated a bunch of systems from between different databases. I've migrated systems from MySQL to Oracle. I think I have migrated systems from Oracle to Postgres and so on. And the thing is, there is always some other difference that makes it like very different, and you still need to be very careful about, for example, handling nulls and empty strings in Oracle, because it handles that differently to for example, Postgres, right? In some cases, it's like empty string is null and stuff like that. MySQL has very different behavior depending on like whether it's strict mode and so on. So I don't think that's really it bugs me, because those are the things that we actually invest into during the development, and then people choose Postgres or any other database and then say, okay, so but we are not going to use the good bits, right?
For example, extended statistics, right?
Yes.
Exactly. Right. Yeah, it's annoying. I agree. Not a good approach. If you chose database already, use it fully, right? Learn it and use it.
I mean, have an abstraction layer. Don't do the queries directly from the front end, for example, or anything like that. Wrap that into like a data access layer or something, but be careful about still allowing the interesting features to actually work.
Right. One of my favorite was at some point I saw the database where developers were actually quite strict about using something non-standard. That time, I think CTE were not part of the standards or something like this, or particular implementation of CTE wasn't. And they told, we don't use CTEs. And at some point I found in the database, it was Oracle, it was like Oracle specific syntaxes for rollups, things like this. It was like normally used in the database. They were simply not aware of if it is part of standard or not. They just took a look on the CTEs and said, that's not, but it's like very, very common approach. If like, let's start going to the end of this talk. Just imagine if someone is in the last year of university and is interested in direction of databases. Which advice you can give, like where to go, what to see, what to do?
So I definitely am not against like new research in databases, right? I'm not saying that Postgres is the best thing that ever happened. I think there are definitely interesting research topics, and I'm not saying that they should stick with Postgres. I'm not sure if I have very good advice for them, except for like keeping their mind open, right? I've been now watching because all I can do is sit at home and watch YouTube, right? So I've been watching some
great in some statistics.
No, I've been watching some talks from CMU about, I think it was called quarantine talks, about different databases, right?
And Andy Paolo, right? Andy Paolo is
yes,
running.
And I think that was excellent overview of like what the databases can do. I definitely think the NoSQL movement was kind of interesting. It was a lot of that was like a bullshit, right? But there was a lot of interesting things happening because of scalability. If you look at like what the NoSQL was trying to do, was about scalability, fault tolerance, maybe doing some distributed database, distributed transactions and stuff like that, and doing that more efficiently than with the relational databases that was possible at that time. And I think Postgres is in like a slightly unique position because it's general purpose database, but we also allow a lot of new capabilities to be implemented in the database. So I think what will happen with Postgres is that we will actually implement some of those features in a good way and allow using that with like sharded databases and so on. And that's what I would like to see, that new people from universities, for example, join one of the Postgres companies and do research like this, and actually help to build either proprietary products built on Postgres or help with developing Postgres itself and getting some of those features into Postgres. That's what I would recommend to people who are actually interested in working on Postgres. Obviously, if you want to actually develop something in like completely new NoSQL database, that can work too, right? Look at, for example, the Cockroach DB. They essentially developed a new interesting database from scratch, right?
Which is SQL actually, not NoSQL. And they took some parts of Postgres also.
I think a lot of the NoSQL databases learned that the SQL is not the problem, right? I mean, like
so
a
new
lot of the
SQL.
NoSQL databases like Cassandra and so on ultimately ended up with implementing some form of declarative language anyway.
Right.
So I don't think the SQL is the problem. But Cockroach is like a relational database, but it does a lot of NoSQL stuff in the background. It definitely is not like the usual NoSQL, the usual relational data store, and so on. But there is a lot of interesting development and research about databases. And what I do like about Postgres is that it's a general purpose database with a lot of functionality, right? And if you plug in your feature into Postgres, you will get the feature, but you will also get a lot of other features that can work with that seamlessly. I would say that for almost any workload, you can probably develop a faster database or a better database, but you will miss like 99% of features that you didn't have time to implement and that are already in Postgres.
And actually that compatibility.
Yes.
Which allows a standard interface to your features.
Yes. It's not only Postgres in core features, but also like whole Postgres ecosystem with all those extensions and products and so on, right? Okay, I think, sorry, you wanted to add something?
No.
Okay. On this positive moment, I think it's time to finish our interesting discussion. Thank you so much, Tomáš, for coming again. It was really interesting and many insights. Thank you. Thank you.
Nikolai will go and create some statistics.
I will go create some statistics, right? Okay, or automate creation of the statistics, multi-column statistics, right? So thank you everyone who watched this and will watch in the future. Please subscribe and like and comment, and we have a Google document where we collect ideas for the next
If
session.
you actually have questions to Tomáš, you can write them there and we will send it to him.
Right.
Yeah, or people can actually write directly to me on my email, which they can probably find in the document.
In the document, yes, we have a link to your personal website, to your blog posts, to recent interview Andreas Schurbaum did. So everything, right? So, and I think we will add more links after this call because we mentioned some interesting stuff as well.
Yeah, well, one more recommendation for people who maybe are at the university or something and are interested in development of databases. It's pretty simple, pretty easy to actually start contributing to Postgres. There is a commit fest which is currently running. The next one will be in March, I think. If you have like idea what you would like to do in Postgres, or are interested in contributing some feature but don't have an idea how to do that or what to implement, we can have a chat. And I'm definitely I'm a committer, but I also try to help people that are new in the commit fest to actually get their first patches done, provide feedback, and so on. So if you are not sure how to start and maybe have never developed anything for Postgres, I'm okay with helping with that. I think that's a very interesting thing. And usually when you have like a commit in Postgres, that's quite valuable for employment actually. So I'm willing to help with that.
Cool. I'm adding corresponding links to our document, so you can easily find it and just jump to this topic. Cool. Thank you so much again.
Thank you, Tomáš.
Yeah, it was interesting. Have a good day, week, and so on. Thank you so much. Bye-bye, everyone.